Hello, my name is Miss Sherry, and we are going to be talking about water conservation. So let's get started. I'm going to share my screen, and here we go. All right, so I work for these guys, the Inland Empire Resource Conservation District, and today we are talking about water conservation. My name is Miss Sherry, and another thing that the IERCD does is we partner with local water districts, and this program is sponsored by the San Gorgonio Pass Water Agency. So let's get started. Okay. So this is what we'll be talking about today. We will be talking about the partnership between San Gorgonio Pass Water Agency and the Inland Empire Resource Conservation District. We're going to take a look at the sources of your drinking water, the State Water Project, how much water that you use. We're going to play a gallon game, and then how much water you can save. So then we'll see what you remember. And I have a little activity at the end. So let's get started. First off, the partnership between the San Gorgonio Pass Water Agency and the Inland Empire Resource Conservation District that we're going to call the IERCD, okay? So the San Gorgonio Pass Water Agency, they've partnered with the IERCD to help students learn about where their drinking water comes from. The San Gorgonio Pass Water Agency manages the water levels that are underground, and they make sure that you have plenty of water now and in the future. They also distribute that water to local water departments, and they promote water conservation. And the way they do that is by partnering with us, and we come and talk to you for them. So you could say that we are ambassadors for the San Gorgonio Pass Water Agency. All right, so we're going to see more. Okay. The hydrologic cycle, or the water cycle. So the hydrologic cycle happens when water, the sun comes up and it heats up that water, whether it's in a lake or the ocean or even a puddle in your backyard. So the sun comes up, warms up that water. What do you think that's called when the water is warmed up? That is evaporation. And evaporation, the water goes up, and then what happens? Goes up into the clouds and becomes, what's that word? Condensation. Condensation is when the clouds go up and they condense, and then they get big and heavy and dark. And what do you think is going to happen then? Then we have precipitation. Precipitation is rain, snow, hail, all that water that's coming down from the ground. That is precipitation. So what happens to that water when it goes down in the ground? Where does it go? Well, some of it will run off and go back into the ocean or in a lake and just run off and go someplace else. Another will fall on the ground and then soak into the ground, and we call that infiltration. Infiltration is when that water is soaking down into the ground, and then that water gets picked up by the roots of the plants and the trees, and then the tree will take up that water, and whatever the tree doesn't need, it will evaporate it back out. There's a water cycle word for that, and it is transpiration. Transpiration, or some people call it evapotranspiration. That is when the tree releases the water that it's not using. And it starts all over again because it is the water cycle, or the hydrologic cycle. Very good. Okay, I have a quick video on the water cycle. Let's just check it out.
All the water on Earth today, every drop, is all the water there has ever been on the planet. Freshwater is actually millions of years old, the same water flowing in a continuous loop, falling as rain and snow from clouds to the Earth's surface, running in rivers, pooling in ponds, flowing from faucets, irrigating crops, traveling through plants, generating power, eventually evaporating into the air and condensing into clouds again.
Why is there life on Earth? And the reason there's life on Earth is because Earth has this perfect water cycle.
The water cycle, so simple even small children understand the basics, yet so complex the most advanced Earth scientists, hydrologists, geologists, and biogeochemists are studying every part and process.
The water cycle is fascinating. It's something that's around us all the time, and yet we don't really understand it.
How to summarize what is known about the water cycle? With two words: flows and stores. The water cycle is a series of flows of water between various water stores or storages. Clouds in the atmosphere.
There's always a little bit of water in the atmosphere. We talked about relative humidity. It's a humid day, it's a dry day. Either way, there's water, sometimes a little, sometimes a lot.
There's a lot of water in the ocean, 70% of all the water on Earth. In the ice sheets and glaciers, 2/3 of all the fresh water on Earth. In the snowpacks atop mountains like the Sierra Nevada. In the Great Lakes, in rivers and streams, in reservoirs and watersheds, in wetlands, in the soil, in and on plants and trees rooted in the soil, and beneath the soil, in water tables and underground aquifers like the Ogallala High Plains, which runs underneath parts of 8 states from South Dakota to Texas. All this storage is temporary. Water in all its forms is always in flux and always moving. And there is a name for every kind of movement in the water cycle, starting with precipitation.
Precipitation is the process of water falling onto the surface of the Earth. You can have precipitation in many forms: rain, snow, hail.
Rain is falling water in liquid form. Snow, ice, hail, and sleet are falling water in solid or frozen form. Fog and mist, falling water in gas or vapor form. Precipitation that falls directly onto the oceans becomes part of surface ocean and can be churned by wave and wind action into ocean currents. Rain and snow that falls directly on rivers and streams becomes one part of stream flow. Rain that falls onto land takes a different path to the river, as does the snow and ice that falls and collects on mountaintops when temperatures warm.
When snow melts, some of it runs through the snowpack and goes into small streams, tributaries that feed into large rivers.
What about that precipitation that falls on and over land? Some is intercepted by vegetation, plants and trees.
Like you might imagine someone in the game of football intercepting a pass. These are raindrops trying to come to the ground, and the leaves on the tree intercept them before they hit the ground.
And the precipitation that does hit the ground, it can run off if the ground is hardscape, covered with asphalt or concrete, or if the soil is too wet or saturated to absorb more water, like an over-soaked sponge. Otherwise, precipitation infiltrates the soil surface, percolates into the ground.
Think of it as the water percolating through your coffee grounds in the morning. Gravity continues to pull it downward where it will move through.
Through the topsoil, into spaces between soil and rock particles, down to bedrock and further into fractures, into deep underground aquifers. Even groundwater here is moving sideways or laterally, discharging toward a river, lake, or the sea. Generally, the deeper the flow, the slower the flow.
Some of that fractured water might take a very long time, thousands to millions of years to get out.
And how does water get back out into the atmosphere? It evaporates, is turned from a liquid into a gas or vapor by the heat of the sun.
If you put a bit of water into a bowl and you set it outside on a sunny day, it's going to disappear. It's still water, it's just in the form of a gas rather than the form of a liquid.
Water evaporates from every wet surface, even from wet air. Some rain and snow evaporates into the air while falling. Water evaporates through our respiration and perspiration. and from plants through transpiration. Trans means through or across. Plant roots rob groundwater.
And plants pull that water up through their stems into their leaves and then release it back out through evapotranspiration.
Evapotranspiration, a spelling bee worthy term for evaporation from soil and water surfaces, plus transpiration from plants. Evaporated water molecules are tiny enough to flow into the air. Mixed with smoke and dirt particles in the atmosphere, cool, condense into visible masses of water vapor, clouds. Winds move clouds into colder air, water droplets collide and merge, grow bigger and heavier until they are so heavy they fall again as rain or snow, sleet or hail. Precipitation, collection, runoff, interception, infiltration, percolation, discharge, transpiration, evaporation, condensation. The water cycle.
All right. So how was that? Okay, now we are going to look at your drinking water sources and where our water comes from. So there are 3 places where we get our water from where we live here in the Inland Empire. So let's see. The first one is groundwater. So groundwater is where the water is stored underground. Remember in the video, they talked about it going down through the topsoil, down into the subsoil, and into some fractured rocks. That is where the water is stored underground. In all those empty spaces, the water will flow. And those are called aquifers. Aquifer is what we call that water that's trapped underground, in between the sand and the porous rocks. So let's see what happens. We have that water, and if that's our number one source, how do we get that water? How do we get that water back up so that we can use it? Well, they use wells. Let's see how that looks. So this is how they access or get the water. The water districts have these wells they've drilled way down into the ground, and they have to go sometimes 400, 500, 600, maybe even 900 feet down into the ground is where they drill for the well. Once they hit water, about 400 feet, they still have to go further down so they can draw that water up. Just like us with a drinking straw. We don't put the straw on top of the water. We put the water down into the cup to draw the water up. Well, that's what these wells are like. So they drill it way down there, and then they turn on the pump, and all that water that's trapped in the ground gets drawn to it, just like a straw. And then the local water departments, they purchase that water from the San Gorgonio Pass Water Agency in our area. And that water gets pumped from the local aquifers, cleaned and filtered, and then sent to your house. So that is the first source of our water. Let's look at the second one. Remember that, it's groundwater, number 1. The second source is the California State Water Project. So here is how that works out. First off, this has been for years and years and years. Northern California gets more water than Southern California. Southern California, we have all the people down here in Southern California. And let me see, you're right about here. So years ago, back in the late 1950s and the early 1960s, the governors and leaders of California were trying to figure out, how do we get that water from Northern California to take care of all the people in Southern California? That's when they started the California State Water Project. And to draw that water down, they built, part of that is the California Aqueduct. So let's take a look at the California Aqueduct. Here is the California Aqueduct. So it was built in the 1960s. And as you see, it's wiggles, it goes all the way down, 702 miles of open canals, that's what you're looking at, or enclosed pipelines. That's what you would see coming down a mountain. So open canals and pipeline, 702 miles long. But if you started at Sacramento and went all the way down to the end of the aquifer, which is around Lake Paris area, it'd be 444 miles. So it's 40 feet deep in a shape of a V, 40 feet deep, but it usually has about 15 to 20 feet of water in it. And across from point to point, from where Ricky is sitting in the water drop, from here to here is about 110 feet across, like the size of a freeway. So you can see the roads, how small the roads are. That would fit 2 cars. And look how large the aqueduct is. It's like a freeway for water. Okay, so that is the second place where we get our water. Remember, the first is groundwater. The second is the State Water Project with the aqueduct. Let's see the third place. Oh, I'm sorry, I forgot. This is a recharge basin. So that water that comes down from the State Water Project, that gets drawn to the San Gorgonio Pass. They use some of that water and they put it in these recharge bins. And these recharge basins will allow the water to soak down deep in the ground. These basins also will capture rainwater. So if we have a lot of rain, then that rainwater can run off down into these basins. And then these basins will let the water go down deep in the ground and refill those aquifers, refill that groundwater. So those are recharge basins. So the water from the State Water Project and excess rainwater and runoff will run into the recharge basins. So, oh, did you know groundwater recharge and storage is the key for water sustainability for the future? We need that. All right, now we'll look at the third source, surface water. So surface water is oceans, rivers, lakes, ponds, streams, creeks, and snow and ice. Yep, even those ice that are up in those glaciers, that's considered surface water. Water that's on the surface of the earth. That is the third source. Now, where we live, we use just a little bit of surface water. We don't use too much of it because we have all the groundwater and we use the State Water Project to refill our groundwater. But let's see what else. Okay, so how much water is there? That is a big question. So, you know that this beautiful globe that we have has a lot of water on the earth. So we have a lot of water. You know that the blue is the water and the green is the land. So out of all this water, how much of it do you think is salt water? I'll give you a minute. How much of all the water on the earth is salt water? From 1 to 100. It is 97% salt water. 97% salt water. Isn't that something? So then that will leave us with what? 97, 98, 99, 100. 3% of water left, which is fresh water. 3% of fresh water left on the earth. So how much of that water do you think is up in the glaciers? In Alaska and in other countries that have glaciers, where do you think? How much do you think? Out of that 3, how much of that? 2%. 2% of all our fresh water is tied up in glaciers. So we don't use that water. We can't use that water. So that leaves 1% of fresh water left over for us to use. And that fresh water is for people, plants, and animals. This is the water. This is portion of this fresh water that comes out of your faucet when you turn on the faucet. This percentage of fresh water is the surface water that's closer to us, or places like Niagara Falls that has fresh water in it. All of this is that 1%. So even though it's just 1%, there's still a lot of water on the earth. So let's see what else. So how do we use this water? So think about that for a minute. How do we use the water that is on the earth? Or how do we use water that comes from our houses or in our area? Let's see. Well, let's see what we decided. We water our plants and fruits and vegetables. We drink water. That's very important, especially after sports. We take showers. We do our chores, washing the dishes, doing the laundry, and we wash our hands. Very important. These are just some of the ways that we all use water. We have to give our pets water too. Can't forget about that. So let's see what else. Oh, we have the gallon game now. So you know what a gallon looks like. You've gone to the store and had to get a gallon of water or even a gallon of milk. That's the measure of a gallon. So how many gallons do you think it takes to grow one apple on a tree? Just one. So you have to get the water and pour it on the tree, let it soak down. And you do that over a period of days, maybe. So you water your apple tree every couple days to get that one apple. How many gallons? Let's see. 33 gallons of water. 33 gallons of water for one apple. Do you ever see an apple tree with just one apple on it? No, they have many more. So that means the apple tree has to use a lot of water to grow all those apples. All right, the next one is this egg over here. So we see the egg. So when you think about this, the chicken has to drink water and the chicken has to eat. We use water to water the plants that the chicken is going to eat. They like corn and grains. And then we also use water to clean the eggs. How many gallons of water to make one egg? Think about that for a second. How many gallons? Okay, ready? Here we go. 50 gallons of water for one egg. Now, when we go to the grocery store, we don't buy just one egg. We buy a dozen at a time. That's 12. So then you can do the math and figure out how many gallons of water it takes for that whole dozen of eggs. But don't do it right now. We're going to move on. What about a 10-minute shower? So that's, you're standing in the shower for 10 minutes, letting all that water fall on you. How many gallons of water do you think it takes for a 10-minute shower? Give you a minute. Okay. Are we ready? Here's the answer. 25 gallons of water. That's 25 gallons of water that is pouring on your head in 10 minutes. Wow. All right. This is a big one. The cheeseburger. This is about a 1/4 pound cheeseburger. So we have to grow the wheat for the bun. We have to grow the lettuce and the tomatoes in your garden or buy them at the grocery store. And then we have cheese, which comes from a cow, right? And the cow has to drink about 50 gallons of water a day so that she can make a gallon of milk. And then we use all of that to make the cheese and then the meat itself. So this is going to be more than 25 gallons. It will be more than 33 gallons. It will be more than 50 gallons. How many gallons of water do you think it takes for one 1/4 pound cheeseburger? Now think about what we've talked about. That's a lot of water that has to be used for different things. Are you ready? Okay, here's the answer. 660 gallons of water for one cheeseburger. That's a lot of water. All right, let's see the next one. Wow. So what is a drought? You've heard that word. We use that word a lot in Southern California because California gets a lot of droughts. We have a lot of droughts. We are experiencing a drought right now. So what is a drought? Do you know? We just don't have enough water. But why do we just not have enough water? What are we not receiving to have not enough water? Here's the answer. A drought is a long period of time with little or no rain or snow. So we are not getting enough precipitation, rain, snow, hail, and that causes a drought. So here are this picture here is in Northern California. Now look at that bridge, and where the bridge is ending, all of this used to have water all the way up. And look at how dry those trees are. My goodness. And then down at the bottom left, you could see all the dry grass there. So let's see another picture. This is another picture in Northern California. So if you're looking straight at the top middle, you can see this little valley here that has a little greenery to it. Well, this water used to go all the way up to there, to that point, and even flowed over, and there was another little smaller lake on the other side. But you could see how dry this area is because we just haven't had enough rain. So this is up in Northern California. All right, so a drought is a long period of time with little or no rain. And we can see that happening now. So since we are in a period of drought, isn't that more of a reason why we need to save and conserve our water? Yes. So we're going to move on. So who needs water? Do you need water? I need water. Let's see. So our pets need water. Whoops, I'm sorry. Let me get back there. Our pets need water, right? And then birds and other animals need water. Squirrels need water. Even the deer need water. All of these animals, every living thing on the planet, including plants, need water. You need water. You need to drink water, especially when you're running around playing soccer or basketball or whatever you like to do. You sweat. You need to replace that water that you've lost. And then this is an example of surface tension. So the water sticks to itself, adheres to itself. That is called cohesion. Water cohesion sticking to itself. And when it's sticking to the leaf like this, that's called adhesion. Adhesion is when the water sticks to something else. So this is an example of surface tension. Let's see what else we have. So how can I help save water? How can you help save water? What can you do? Think about that for a second. What can you do? Let me see. What can I do? Well, let me show you what we came up with. You can check your house for leaks. You can go look at your bathtub, your kitchen sink, your faucets, make sure that they're all tight and they're not dripping. You can check your toilet and make sure that it's not making that running water noise. That could be something so simple, like maybe the flush just needs to be fixed. So those things can be handled very easily. Another thing is don't forget to check for leaks on the outside hoses. So you might have a hose leaking and making a big mess of water out there and wasting that water. So check your outside of the house also. Turn off the water while brushing your teeth. That's a big thing. You don't need all that water running while you're brushing your teeth. Just turn it off. Remember how much water it took for a 10-minute shower? What was that? 25 gallons of water? What if you took a 5-minute shower? Set your timer, put a couple songs on the radio when those, or whatever you're using. When the songs are done, you know it's time to get out. So 5-minute shower helps to save a lot of water, right? Oh, did you know the amount of water coming out of your shower is 2.5 gallons a minute? 2.5 gallons a minute. So a 5-minute shower is probably about 13 gallons of water coming out of the shower. All right, let's see what else. What can we do? We can check your sprinklers to make sure that they're working correctly. Make sure that they're actually watering the grass and not the sidewalks, or they don't have a leak or they're broken. You can also use a broom to sweep your driveways and sidewalks instead of hosing them down with a hose. Use a broom. It's good exercise and it's helping to save water. Here's another thing. Plant California native plants or drought tolerant plants, plants that can survive with a little bit of water. California is full of those kind of plants. So that's why we can go to places and see all these plants where we don't ever have sprinklers or hoses out there in the wild, but yet the plants are still surviving because they're drought tolerant or in low water, and they might be California natives. So like the California poppy, which is a California native plant. We also have the succulents, which hold all their water in their spongy leaves. So they can survive with just a little bit of water. So that's another thing. Those are a couple of things that we can do. Let's see something else. Oh, this is what we do at the IERCD. We have a department that is the natural resource team, and they monitor project sites outside. They make sure that everything is going well, that the plants that are there should be there. They make sure that the native plants are doing well. It's a tough job. They restore the area and make sure that it is growing and as it should be. We also have a community conservation community team, and we go out, and that's me right there. And we have events, or we go to events. This one's in Yucaipa. And we talk to people about the environment. We talk to them about soil and water and plants and do all kinds of things with the community. And we also have our education programs, which we're doing right now. So that is something that we do at the Inland Empire Resource Conservation District. Let's see what else. Do you remember? So let's see if you remember what we talked about. First off, what are the sources of drinking water here in the Inland Empire? Is it A, or 1, oceans, rain, and faucet? Is it B, or 2, groundwater, state water project, and surface water? Is it 3, or C, rivers, mountains, and lakes? What do you think? What did we talk about? What did we talk about? So, what are the sources of fresh drinking water here in the Inland Empire? It is B, groundwater, state water project, and surface water. Let's see what else. How can you save water in your home? Can you A, check for leaks around your house? B, take a 5-minute shower? Can you C, plant native and drought tolerant plants? Or D, can you do all of these things? What is your answer? A, B, C, or D? Here's the answer. It is D, of course. We can do all of these things to help save water. I think there's one more left. So what does the San Gorgonio Pass Water Agency do? Do they A, manage and recharge groundwater levels? Do they B, promote conservation and education? Do they C, distribute water to local water departments? Or D, do they do all of things? Are all of these answers correct? Correct. What do you think? A, B, C, or D? What is your answer? All right, here is the answer. D, yes, another one. D, of course. They do all of these things. The San Gorgonio Pass Water Agency manages and recharges groundwater levels. They promote conservation and education by working with us, and they distribute water to local water departments in your area. Very good. Okay, so this is the front of San Gorgonio Pass Water Agency. You might have even driven right past them. So you can follow us on social media at Pass Water Agency for the San Gorgonio Pass, and at Inland Empire RCD to follow us, the Inland Empire Resource Conservation District. All right. And you can also look at our websites, iercd.org and sgpwa.com. thank you for letting me come into your classroom today. And I hope you have a great rest of your day. Bye-bye.